Hi everyone, hope all of you are doing well. In this video, we are going to talk about sampling distribution of a proportion. But what is a proportion? A proportion is a fraction or percent of a sample or population with a particular trait of interest. For example, let me explain on an example. For example, if in a class there are 10 students, so just suppose I have a sample of 10 students in a class. If out of these 10 students, just 5 of them wearing glasses, then the proportion or percent of the proportion of the students wearing glasses in this class would be 5 out of 10 because we have a class of 10 students, 5 of them wearing glasses. The particular trait of interest is wearing glasses. Okay, now the proportion of the students wearing glasses would be 5 over 10 or half or 50% of the students in the class, in this class wearing glasses. So look at here. If the number of items with a particular trait of interest selected from a sample, okay, and n is sample size, p bar x divided by m would be the sample proportion. If I calculate the proportion of the items with a particular trait of interest on a sample, I have sample proportion. But what happens if x number of items with a particular trait of interest in a population? Then I'm going to calculate, I can calculate population proportion. Okay, P. I show population proportion, we show population proportion by P. Okay, X represents the number of items with a particular trait of interest in a population, and we have the population size, capital N. So P bar is sample proportion, P is population proportion, capital N is population size, lowercase n is sample size. Now let's talk about P bar, sample proportion. So we are going to talk about distribution of P bar, distribution of a sample proportion. So look at it. If these two conditions fit, if sample size, n is sample size, times P is population proportion. If sample size times population proportion is more than 5, and sample size times 1 minus population proportion also is more than 5, the distribution of P bar, the distribution of a sample proportion would be approximately a normal distribution. So distribution of P bar proportion of a sample is approximately a normal distribution. Okay, if these two conditions fit, okay, we have a bell shape for the distribution of P bar. For the normal distribution, in the middle, we always have the mean value. Okay, how much is the mean value of this of P bar? The mean value of P bar is population proportion. So in the middle, I have P, population proportion. It's the mean value of P bar, the mean value of the distribution of P bar. What about its standard deviation? Because as you know, any normal distribution has two parameters, mean and standard deviation. What about the standard deviation of this normal distribution? The standard deviation of this normal distribution is sigma p bar because it's a standard deviation of distribution of p bar. I'm going to show you, we show that by sigma p bar. Sigma p bar is a square root of p population proportion times 1 minus population proportion over sample size. We call that the standard error of the proportion. It's the standard deviation of distribution of p bar. Okay, because P bar is approximately a normal distribution, I can convert that to a standard normal distribution by calculating Z for P bar. By using this formula, P bar minus P over sigma P bar. Look at here. I can write in summary, Z is P bar, sample proportion, minus population proportion divided by a square root of P times 1 minus P over N is sigma P bar. So, okay. So by using this formula, we can convert the normal distribution we have here to standard normal distribution, and then we can find the probabilities for P bar by standard normal distribution. Okay, let's go and solve an example. Look at here, question says Atlas Corporation receives a shipment of flour every morning from its supplier. The flour is in 50-kilogram bags, and Atlas will reject any shipment that is more than 6% underweight. Look at here. If the question says, if the proportion of underweight bags is more than 6%, the shipment will be rejected. So we already have the population proportion. We look at the shipment as a population, okay? If the proportion of underweight bags is more than 6%, the shipment will be rejected. So population proportion is 0.06. Question says, what is the probability that in a sample of 160 bags, now we have a sample size is 160 bag. What is the probability that in a sample of 160 bags, the foreman will find that less than 4% are underweight? Okay, so we are going to find the probability that the proportion of underweight bags in this sample of 160 bags is less than 4%. So I'm looking for this probability. I'm going to use capital P for probability because population proportion also is P. Look at it, it's capital P, it's probability. So probability that the proportion of the underweight bags is less than 4% in this sample. So look at it, I'm working on a sample proportion. Sample proportion, the proportion of underweight bags in the sample is less than 4%, 0.04. I need to find this probability. Okay, so look at here. I know P bar is a normal distribution, so it's bell-shaped. And what is the mean value? In the middle, we have the mean value of this distribution, which is a normal distribution. Okay, I know the mean value of the distribution of P bar is population proportion. So in the middle, I have population proportion. How much is population proportion? 0.06. So in the middle, we have 0.06. It's the mean value of P bar, mu P bar. Okay, 0.06 is here. Now I'm looking for this probability that P bar is less than 0.04. So look at here, 0.04 is here. It's on the left side. It's less than 0.06. So here I have 0.04. So here we have 0.04. All the P bars less than 0.04 are on the left side of 0.04. So the probability I'm looking for, so X bar is, or P bar, we work with P bars. All the P bars less than 0.04 are on the left side of P bar. They are located here. So I'm looking for the area of this part. It's the probability that I'm looking for. So this probability is the area of this part. I can find the area of this part, the area of the shaded part, the area of the red part easily by Excel. Just I need to convert P bar 0.04. I need to convert that to Z by this formula. Look at here. By this formula, we need to convert. Let me write that for you. So look at here. P bar is 0.04. I need to find the Z value of P bar by P bar minus P over a square root of P times 1 minus P over N. Okay, so P bar is 0.04, P is 0.06, so N is 160. Just I need to find the Z value of P bar, and then after finding the Z value of P bar, I need to find the area on the left side of Z value or P bar, okay, by using standard normal distribution in Excel, norm, period, S, period, distribution, and then Z, we can find the area on the left side. Let's go to Excel to find the probability we look for. Look at here, it's the Excel file for the same question. So population proportion is 0.06. Its sample size 160. Let's find sigma p bar or square root of p times 1 minus p over n first. So I need a square root function. P is 0.06 times 1 minus p. Then I'm going to divide by sample size 160. Then close the bracket. Look at here, it's a standard error of the proportion or 0.0188. I need that in Z formula because Z is P bar minus P over this square root. Okay, so now let's find P. Let's find Z value of P bar. P bar is 0.04 minus P 0.06 divided by sigma P bar, this square root. Look at here, Z is minus 1.07. Now it's the probability I'm looking for. To find this probability or the area of the red part, the area of the shaded part, just I'm going to use, look at here, I'm going to use norm standard distribution. Look at the formula, norm standard distribution, because I'm working now with Z. Z is minus 1.07 and it's always cumulative. Here I'm looking for the area on the left side. Just this function always returns the area on the left. So the probability I'm looking for is 0.1434. So this probability is 0.14. Now we have the answer, 0.1434.